When we are graphing an inequality, we get to the stage where we have to shade one side or the other, and we figure out which side to shade by doing a test point. We follow a rule: never use a test point that is on your line. And I'm going to illustrate why you should not use a test point that is on your line. Here I have the inequality x plus y less than 2. I have already prepared a table of values, and I've already graphed the line. What I'm showing here are 3 test points. One that's on the line, 0, 2, and 2 others, 3, 1, and 0, 0, that are not on the line. One of them's on each side. I'm going to test all 3. First, using the point I'm not supposed to use as a test point, 0, 2, I plug x equals 0, y equals 2 into this inequality, and I get 0 plus 2 less than 2. This simplifies to 2 less than 2. 2 is not less than 2, so that is false. Normally a false is a perfectly good result to tell me which side to shade, but the problem is, now which side do I shade? I don't know which side to shade because I picked a point that's on the line. Sure, plugging in 0, 2 into that inequality tells me that 0, 2 is not part of my answer, but I already knew that. I knew that when I had the less than symbol and not the less than or equal to symbol, I should put a dotted line to show that I know the points on the line are not part of the answer. I still don't know which side to shade. This is an ambiguous situation. Do not use a point that is on your line as a test point. How about if we use 0, 0? That's usually everybody's favorite test point. I'm going to plug 0, 0 into this inequality, and I get 0 plus 0 less than 2, which simplifies to 0 less than 2. That's true. When I get a true statement as a result of my test point, it means I shade towards the test point. From the line, I'm shading towards 0, 0. That means I'm shading over here. Let's try the test point 3, 1, which is on the other side of the line. Plugging the x equals 3 and the y equals 1 into the inequality, I get 3 plus 1 less than 2, which simplifies to give 4 less than 2, and that's false. This time, though, my false result tells me where to shade. Since I got a false result from a point that's over here, it means that point is in a region that is not part of the answer. I should not be shading that region. I should be shading the other region. Either of these test points gives me a result that tells me which side to shade. But if I use a point that is on the line, I get an ambiguous result. It doesn't tell me which side to shade, and it was a waste of time. Remember, always follow the rule. Do not use a point that is on your line as your test point. Here's another example. Let's try doing our test point with this situation. We have the inequality y is greater than or equal to x. I've already made a table of values and graphed the line. It's time to do the shading. If I use a test point 0, 0, a point that is on the line, let's see what happens. When we plug 0, 0 into this inequality, we get 0 is greater than or equal to 0. Well, since 0 is equal to 0, this is true. But it is ambiguous. It tells me that 0, 0 is on the line, but I already knew that. It doesn't tell me which side of the line to shade. Let's try using these other 2 points as test points and see what happens. If I test 0, 3, I end up with 3 greater than or equal to 0. That is also true. Since I have a true result from my test point, from the point 0, 3, which is up here, that means 0, 3 is in the answer. It's part of the shaded region. So I'm going to be shading up here. Let's try the point 3, 0. If I plug 3, 0 into this inequality, I get 0 greater than or equal to 3. That's false. This tells me I have to shade away from that test point. Well, 3, 0 is over here, and shading away from it, from the line away from this test point, means shading up there. Either of these results is telling me to shade this part of my graph. Either of them is a good test point to use because they are points that are not on the line. You don't have to get a true result. A true or a false will do. Follow the rule. Always use a test point that is not on the line.